This is the bottom flap of section number 1 in your Unit 3 Quadratic Functions flipbook. Again, this is maybe a little bit of review for some of you, but let's talk about this so we understand the difference between linear and quadratic. So our essential question on this section is, what is the difference between a linear function and a quadratic function? Students, make sure you are writing down your essential questions for each of these sections in your flipbook. That way, if you have a question while you're doing homework or quizzes, you can go back and take a look at the question that we were answering in this section. So what is the difference between a linear function and a quadratic function? So I filled out this first part right here. This example, this function f of x equals 4x minus 8 happens to be a linear function. And how do we know it's linear? The main way that we know is we're going to take a look at the exponents on all the input values. So here is our only input value. Here is x, that is our input. Remember, f of x is our output or our y value. X is going to be our x-axis value or our input value. The exponent on this x is not written, and that means the exponent for this variable is 1. And that means, based on what we've previously learned in class, in your notes, is that this particular polynomial or function has a degree of 1. So this is an equation or a function with a degree equal to 1. And a degree equal to 1, that is what defines a linear function. The other thing you would be able to do is, if you graph this, if you plugged in 3 or 4 values for x, and that was your input, and you got out values for your y-axis, which is your output over here, you would find that this particular equation graphs a straight line. That line, it could be looking something like this. It might be positive slope, maybe it's a negative slope, but linear functions will always graph as a line. The shape of the graph will be a line. This is different from a quadratic function. Take a look at the bottom one now. F of x is equal to 2x squared plus 4x minus 8. In this case, what defines a quadratic function is the fact that we have this exponent right here. I'll circle this one so we also circle it the same way as the last one. This exponent is 2. That's the largest exponent on our input variables. And so that defines this equation as an equation with a degree of 2. Now it wouldn't matter what order these terms were in. It could have been negative x plus 4x plus 2x squared. Look at all your exponents, and the highest exponent, the largest exponent, defines a degree. And I just realized right now, class, that I wrote degree equals 1. This is actually a degree equal to 2. That defines it as a quadratic function. And the other way we can determine this is if we plugged in 3 or 4 or 5 points into, or 5 x values into this equation and found out the 4 or 5 outputs that go with them, we would find that this graph actually creates a U-shaped graph. Sometimes it faces up. Sometimes you might see it faces down, and that will define a quadratic. Okay, so up here, let's finish this up. I want to make a note here. This will graph as a line. And a quadratic will graph as a, and let's give it a name. This name of this shape, this U shape upside down or right side up U shape, is called a parabola. There's a new term you need to know. It graphs as a parabola. Every quadratic function will graph either as a right side up parabola or an upside down parabola. So knowing this now, let's take a look at our questions. Is this function linear or quadratic? You should pause the video right now, class, and based on what you've learned here, see if you can answer these. Just answer them in pencil. Once you've gone through all of these, then start the video back up again and see if you got the answers correct. I'm going to go through the answers right now, assuming that you paused now and tried this out. F of x equals negative x squared plus 8. We have an exponent on our input variable that is 2. That defines this as a degree equal to 2, and that means it is a quadratic. Take a look at the next one. F of x is equal to 12x minus 6. Our largest exponent in this equation or function is 1. That means our degree is equal to 1, and that is linear. Next one, g of x is equal to 2x. Notice I don't have to have anything else with it. Just check your input variable. What is the largest exponent in this equation? It is still 1, and that means this function is a degree equal to 1, and this one is linear. Let's take a look at the next one, h of t. So now we changed our function name, no big deal. In fact, we changed it in the previous one too. Function h, or h of t, is equal to t plus 5t squared minus 7. Now notice, it doesn't matter in this case the order of our terms. This is a t to the first power. This is a t to the second power. That's our largest exponent. That means the degree of this function is 2. And I'm just going to abbreviate this now. This is a quadratic function. Next one, f of x is equal to 5x cubed minus 2x squared plus 9. Notice the largest exponent is 3. And that means, class, this has a degree of 3, or degree equal to 3. It is not linear, and it's also not quadratic. So we're going to say in this case, this is neither one. This is something you'll actually probably explore in Integrated Math 3. And the last example, f of x is equal to 0x squared plus 7x. Now this one's a little bit tricky. We know that this x has an exponent of 1, and this x has an exponent of 2. But by putting a coefficient of 0 with this, you know that 0 times anything just gives you back 0, and that means technically this term does not exist. It just evaluates at 0, so we don't look at this exponent anymore. Now we're just left with an exponent of 1. That means this one, this tricky one, is actually just a degree of 1, a function with a degree of 1, and that one will still evaluate as linear. That will be a graph of a line.